Hello, today we'll be looking at cardinality of a set, empty set, subset, then power of a set. Are you ready? Let's proceed. Now, what is a set? Everything we are having here says set. We said a set is a collection of unique objects that can be seen as numbers or elements. Now, a set is just collection of items that are common. Does it make sense? For instance, if I go to a school, I'll say sets of students in just as one class. You see many students. You see the ones that are 10 years old. Do you understand? 9 years old, 11 years old. So that's what we mean by what? Set. Collection of items that have unique properties. For instance, sets of phones. When I say sets of phones, we have iPhone, we have Samsung, we have different brands. Cars, we have Mercedes Benz and so on. You understand? For something to be a set, for those elements, the members seen in a set that are called elements of the set. That are called elements. For instance, if I say that set A has the element, if the elements in set A are one and what two, one and two are said to be what? The elements of what? Set A. Now, well, can you see something? These two things. These two things are called curly brackets. For something to be a set, this curly bracket must exist. For instance, if I have something like A is equals to 1 to 10, this is still not a set. There must be presence of curly what? Bracket for it to be what? A set. I hope you understand. So let's leave the definition of set, then let's go to cardinality of a set. Now, what do we mean by cardinality of a set? Cardinality of a set refers to the number of elements contained in a set. Now, cardinality of a set, it is denoted by n, meaning number. For instance, this set that I wrote up here, when I say what is the cardinality of set A, the answer, how many elements can you see in set A? The answer is pure 2. Very simple something. If I have set B and I have set B refers to the prime factors of 10. Prime factors of 10 are 2 and what? 5. So therefore, the cardinality of set what? B. How many elements can I see in the prime factors of 10? That's definitely 2. If I have that set C has the element from what? If I have that set C has the element A, B, I, J, M. These are the elements of set C. Then they ask you, what is the cardinality of set C? How many elements can you see here? 1, 2, 3, 4, and what? 5. So the cardinality of set C is 5. I hope you understand. So we've explained what we mean by cardinality. Let's explain what we mean by empty set. An empty set is a set that has no what? Element. Any set that has no element is what? An empty set. For instance, if I say set of pregnant men, that's not possible, having pregnant men. So that's an empty set. We have no pregnant what? Man. Do you understand? Something like that. Okay, let me use numbers to give an example. If I say set of the prime factors of 1, prime factors of 1, watch out. For us to get the factors of any number, we must get for us to get the prime factors of any number, we must first of all get the factors of that number, then check those ones that are prime. Now, prime factors of 1, first thing I do is to write out the factors of 1. Now, the factors of 1 is 1. That's the only number that can divide 1 without giving any remainder is what? 1. So out of this 1, there is a prime factor of 1. So there is a factor of 1. Is there anything that is a prime number here? Because prime factors of a number are those factors that are prime numbers. So this factor, is it a prime number? No. So if I have that set F, as in is given by the is given by the elements being the prime factors of 1. The answer is definitely what? Empty set. An empty set is denoted by this or this. When you see something like this, as in a curly bracket without anything written inside, is an empty set. Or you see it as this thing that looks a bit like 5, but it's not 5. Does it make sense? Now, what do I mean by it? 1 is not a prime factor of 1. Yes, because 1 is not a prime number, dear. 1 is not a prime number. A prime number must have 2 factors. Does it make sense? So 1 is not a prime number, therefore 1 can never be a prime factor. Do you understand? Make some research on that. So when I say that set G is equals set of pregnant men, we don't have any pregnant men, so the answer will be what? An empty what? Set. an empty set, which can be seen as this or this, curly bracket without any what element. I hope you understand. So by now you understand what we mean by empty set, something that is not possible. Now, subset. Listen to me, be very careful. When I talk about subset, I use two things. Set A is a subset of set B if and only if all the elements in set A are contained in B. I hope you understand. If I have two sets A and the elements in set A are 2, 6, 8, 10. So in set A, then in set B, the elements in set B are 1 to what? 1 to 15. Now, I will say that set A is a subset of what? Set what? B. Reason, because all these numbers that I can see in 2, 6, 8, and 10, I can equally find them from 1 to 15. Therefore, I will say that A is contained in what? B. I will say that B what? Contains what? A. I hope you understand. Note these things. Note these symbols. I hope you understand. So if I say that set P is a subset of set Q, what do I mean? I mean that all the elements in set P can be found in set Q. If I say that set H is not a subset of set Z, it means that not all the elements in set H can be found in set Z. Please note these things that I'm saying. So by now we understood what we mean by what? Subset. And since we've talked about empty sets, note that an empty set is a subset of every other set generally in this world. An empty set, a set without any element, is what? A subset of every other set. Do you understand? So if I want, for instance, now, if I have set P having the element A, B, and C, and they ask me what are the possible subsets of this set. Now, what are the sets that I can bring out? I can have set what? A set having only what? The element A. I can have a set having only the element what? B. I can have the set having only the element C. I can have the set having only the elements A and B. I can have the set having the element B and C. I can have the set having the element A and C. I can equally have the element, I have the set having the element A, B, and what? C. Then lastly, I will have the set that have none of these what? Elements. So you see, these are the possible subset of this set P. So we say that set A as in set H is a subset of set I if all the elements in what? Set H can be found in set I. Now you see this thing that I've done here, that's what leads us to power of a set, and that's the last thing I will do here. Now, power of the set refers to all subset of a set. All the possible subsets you can find in a set. Now, what are set P that I used initially? The elements in set P, A, B, and C. Now, all the possible subsets I can find in A, B, and C. I have A, B, C. This one, right? 1, 2, 3, 4, 5, 6, 7, and what? 8. We have 8 possible subsets of this set. So power of set P, which can be written as P subscript P, is equals what? 8. Because these are the possible subset of set what? P. I hope you understand. Now, if I have the set, I have set what? A, as in the elements are rice and what? Beans. Do you understand? Then they ask me, wait, we don't put capital letters. Rice and what? Beans. We use small letters. The elements in set A are rice and beans. Now, and then I ask you, what is the power of this set? Now, the power of a set, I can say, let me explain very well, refers to the number of choices that can be made pertaining to the elements of a set. Now, if I have rice and beans, if I bring out rice and beans, then I ask people, start choosing. I ask 4 people, start choosing. Now, watch out. The first person can say, I like rice. The next person will say, I like beans. The next person will say, I like both rice and what? Beans. Then one person will come and say, I don't want any of them. I don't want rice, neither do I want what? Beans. So you can see that the possible subset of this set what? Of this set A, having rice and beans. How many subsets do we have? We have the set, the person say that I like what? Rice. The next person say, I like what? Beans. The next person said, I like both rice and what? Beans. Then the last person came and said, please don't give me any of what? Rice and beans. I don't like any of them. So what is the power of set A? We see that the power of set A is given by 4 because the possible subset of this set A, we've gotten 4. Now, if you're in an exam hall and these people ask you questions based on power, will you start writing all the possible subsets? Listen, most times, even not most times it's not possible. Watch out. If I have let's say set B, and the elements in set B are from 1 to what? 20. Then they ask you what is the power of set B. Will you start checking all the possible elements that 1, 2, 1 and 2, 1 and 3, 1 and 4, 2, 2 and 3? It makes no sense. Hence, the formula, power of any set is given by 2 raised to power what? N, where N refers to the cardinality of that set, the number of elements in that set. That's what it means. Now, watch out now. Watch what I mean. Power of set P. Since we said that it is given by the formula 2 raised to power n, where n is cardinality. Now, cardinality, the number of elements in set P, we have 3, right? 2 raised to power 3. Is it not 8? It is. So can you see that we got it even way faster than writing all the elements? Now, power of set A, 2 raised to power n. What's the number of elements in set A? 2, Abi. 2 raised to power 2. Is it not 4? We got 4. So you that is watching this video, give me the power of set A having the elements first 5 prime numbers less than 40. If I have set A and the elements refers to first 5 prime numbers less than what? 40. Give me the power of set what? A. Please put your answer in the comment section. I'll be very glad to see one. Have a nice day. Like, comment, share, and follow Cozi's Academy. Bye-bye.